what a status register is?
Sir,
What is a status
flag,
register? Yeah. What flag?
सर वो इवेंट के लिए फ्लैग हाई या लो होता है।
Which event?
सर कोई भी
कोई भी क्या?
सर अरिथमेटिक ऑपरेशन या कोई भी ऐसे ऑपरेंड प्रिपरेशन हो उसका इवेंट।
सर किसी भी इवेंट या ऑपरेशन के बाद फ्लैग हाई या लो होता है।
कौन सा फ्लैग होता है बेटे? Which flags are there? So actually, the status register will be updated after any operation. So there are two type of instructions. Okay, so if you look there are different type of instruction in a microprocessor. One is a data transfer instruction. Another is data transformation instructions. Okay, so what is the job of a microprocessor? Gee, what is the job of a microprocessor? So I'm highlighting what's the job of a microprocessor. So microprocessor perform three operations. Microprocessor can perform three operations. What are these operations, G?
Sir, input, output, and processing.
So microprocessor performs three types of operation. Three types of operations. What are these operations? Number one, data transfer. Data transfer. One instruction is data transfer instruction. Another is data transformation instruction. Data transformation instruction. Another example is control instructions. Okay, so these are three different type of instructions that are available in a microprocessor. Widely, it's a wide categorization of different type of instructions. So what is a data transfer instruction? Okay. So what is the state of the microprocessor? What is the state of the microprocessor? G, what is the state of the microprocessor? The state of the microprocessor. G, microprocessor based system. So the state of the microprocessor based system is determined by the content of, so now there are two contents. The content of number one, registers, and other, what are the other contents? Where the data is stored?
Memory.
Yes, memory. So it means if we say that what is the state of a microprocessor or a microprocessor based system or the overall system, so it means that the state of the microprocessor is determined by the content of the registers. So actually, if we study different type of instructions, and for each instruction the state is changed. Either the value of a register is changed, or either the value of memory is changed. Am I correct or not? Ji beta.
Yes, sir.
Okay, and if you look at the register, so if you look at the register, so register consists of, okay, what are the type of registers? Which register did we study? Ji bataye beta. Program counter. Okay, we will study it later on. Program counter, address register.
Yes.
Then data register, and then stack pointer. And there is also one status register. We will now study the status register. And what is the memory? If we look at the memory, so memory stores some data. So what memory stores? Memory stores instructions. Am I right? And memory stores data.
Yeah.
And we also, if we look at the data, there is also some stack. If you look at the data, stack is also a form of a data. And what are the different operations of a stack? What are different operations of a stack that we studied? Gee, which operations did we study in the last lecture?
Push and pop.
Push and pop.
Push and pop. So actually, if you look, if you look at a microprocessor, so in the microprocessor, how the state of the microprocessor is defined or determined. So the state of the microprocessor is determined by the content of the register. There are various type of register. Program counter is a register. There are various address register in our architecture. In our assume architecture, we assume that okay, there were 16 address register, there were 16 data register. We have a stack pointer, we have a status register. We will now study the status register now. And now, if you look at the memory, so memory is used to store the instructions. There are different types of instruction: add instructions, subtract instruction, move instructions. Okay, and and move instructions. And we also store some data in memory. Definitely, we want to store. Let's assume if we want to store an array. If we want to store an array, we store the whole data in memory, because you cannot fit if the array size is large, you cannot fit all the data in the register. So what you have to do, you have to store this data in memory, and that is we store the data in memory, and that data is actually pointed out by an address register. Am I right or not? Okay, so if okay, so there are various different type of instructions of a microprocessor. What is a data transfer instruction? G. So now we studied a data transfer instruction. G. What is a data transfer instruction? G.
Move.
Yes, move. Move is a classical example of a data transfer instruction. So actually, what if we want to data transfer data? So actually, so what can what are different type of data transfer instruction? So actually, so we want to transfer the data. So we want to transfer the data. So either the transfer of data can be between two registers. Am I right? Hmm?
Yes, sir.
Between a register and memory. Did you get my point or not? So either you need to transfer the data between two registers. Like let's assume, so what between two registers, so what is the classical example? Let's assume if we say move R5, R9. What are you doing now in this instruction? You're moving the contents of R9 to
R5.
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 Between a register and memory. Between a register in memory. So if you have a between register in memory, and between a register in memory. Okay, so what are the classic? So register can between a register can and memory. So there are two types of instruction. So it means that it will be if it's between register and memory. So register can be source. Register can be a source or destination. Similarly, memory can be source or destination. And we use different. Okay, if we are using a register addressing mode. Okay, so if the destination is register, which addressing mode do we use for register? If the destination or source is register.
Direct.
No, direct. In direct addressing mode, data is in memory, beta. If source, G beta.
Sir, indirect.
No, indirect is also the data is in memory, beta. The data is in memory. If we want to move some value to a register,
Immediate.
Immediate.
Immediate is a so the register addressing mode, beta. This ये जो कर रहे हैं, which addressing mode is this?
Register.
Register addressing mode. So if so, it means now it is the source, and now it is the R5 is now the destination. And which addressing mode did we use for? If register can be either a source or either destination, so which addressing mode is used?
Register.
Register addressing mode. Okay, so now if you transfer the data, so it can be between a register and memory. Oh, now if the operand is in memory, so which addressing mode we can use? If the operand is in memory, कौन-कौन से addressing mode हो सकते हैं? If the operand is in memory, direct and absolute. Then register indirect. And there are various invariants of this register indirect. Which are these variants? Pre-decrement,
Post-increment.
post-increment, and displacement. Am I right? And we also have another addressing mode. कौन सा addressing mode था जी बताए बेटा? Stack. ठीक है. अच्छा. So now we can move the data between two register. Between a register and a memory. Register can be era or between two memory location. Between two memory locations. Between two memory locations, between two memory location. It means that the source is also the memory and destination is also memory. It means that we want to move the contents from one memory location to another memory location. One classical example, I will give this when an example. If we say move, move. Now I'm using a move instruction. Move A9, comma. Now I'm using this. I'm using the curly brackets just to avoid the confusion. Move A9 $1, 2, 3, 4. Okay. Which addressing mode is this one? On the left hand side. Which addressing mode is this one?
Indirect.
And which addressing mode is this one? G.
Sir, immediate.
No, it's not immediate. Immediate is represented by hash.
Oh yes, sir. Direct.
So it is. So it means between two memory locations. So it means that the source is also memory and destination is also memory. So now in this example, so let's assume I will give this with an example. Itni examples I do it so many examples and then you forget everything. You forget everything. That's a problem. So now let's assume that you have $1, 2, 3, 4 is an address, and let's assume this is an A5. This was A9, and let's assume A9 is pointing to 3320. So this is 3320 $3320. So it means this A9 is pointing to this location. So if you look at this, this is destination. So this memory location is the destination. This is the source. So let's assume that this contents is $1166, and let's assume this value is $0000. So now this is the destination. So this value will be overwritten, and what will be the new value?
$11166.
No, 1166. Okay, you got my point. So now if you look at this, this is the destination. Destination is memory. Destination is memory. So this destination is memory pointed out by address register A9. So this A9 is pointing to this memory location. So this is your destination. Destination is memory. And now this is your source. And this addressing mode is direct addressing mode because now this is the direct addressing mode. So this is the direct addressing mode. बेटा समझ आ गई बात या नहीं आई? And for God's sake, please concentrate on the lecture. Please concentrate on the lecture, and then you don't revise. You don't revise your previous lectures, and that's the reason that I ask any question, everybody's blunt then. So please revise your lecture before discussing the new topic. Otherwise, it will be very difficult for you to. And in our next lecture, we will then study more complex programs. We will write more complex program. And when we write more complex program, if you don't know the addressing mode, so it will be difficult for you to write assembly program. Please revise all these lectures. Okay. So now if we say that, okay, microprocessor perform three type of operation. One is the data transfer instruction. So the data transfer instruction is move. So this is now one. So if this is the data transfer instruction, so this data transfer instruction is the classical example is move. So we move the data between two registers. We move the data register between a register and memory. The register can be a source or destination. Memory can be a source or destination. And we also transfer the data between two memory location. And in the data transfer instruction, we can also move an immediate value. So we can also move an immediate value. Okay, so immediate value. So you can also move an immediate value, and it is also a source. So immediate is also always a source. Am I right or not? Am I right?
Yes, sir.
Oh, so you can also move an instruction. So, okay, what is the example of data transformation instruction? Data transformation instruction. So, what is the example of data transformation instruction? G. What is a data transformation instruction? Data transformation instruction. G. What is a data transformation instruction? Can anybody elaborate? I mean, okay, so what instruction did we study now previously? G. Which instruction did we study now? Move data transfer instruction.
Yes, sir.
What's the job of a data transfer instruction? G, बताएं बेटा. Anybody, please.
सर रजिस्टर से मेमोरी में मूव करना है, रजिस्टर से रजिस्टर मूव करना, ट्रांसफर करेगा.
Transfer. And what about data transformation? Data transformation. What does data transformation means? Transform means what is the data transform?
कोई प्रोसेस परफॉर्म होगा, वो चेंज हो जाएगा डेटा.
Yes, perform an operation on the data. What are different operations on the data?
सर एडिशन, सब्ट्रैक्शन, मल्टीप्लिकेशन, डिवीजन.
Very good. So it performing an operation on the data. So it means add instruction, subtract instruction, multiply instruction, divide instruction, shift instruction. We will study these type of instructions. It performs a transformation on the data. So it will perform a transformation on the data. So if we say that if we have an instruction add R3, R2 and R1, so the contents of R1 and R2 will be added 0, 0, 1, 1, 0, 0, 2, 2, and let's assume the destination is R3, and let's assume the R3 value is 0, 0, 0, 0. So it means it will add the contents of R1 and R2. So the new contents will be 0, 0, 3, 3. So this is a data transformation instruction. So it performs an operation on the data. So if you look at it here, so the contents of R3 is neither the contents of R1 and neither the contents of R2. So it's new contents. So it means it performs some operation on the data and it changed the data. So the second type of instruction is a data transformation instruction. Okay, now the third type of instructions. So the third type of instruction is, if you look at this, so what's the third type of instruction? G. कौन सी instruction अभी study की है? Elaborate किए जी. What is the third type of instruction?
Control instruction.
Control instruction. G. Control instruction. What is the control instruction? G. G. What is the control instruction? Can you elaborate any example of a control instruction? G. Can you elaborate an example of?
जैसे सर इंक्रीमेंट कहते हैं, वो नेक्स्ट रजिस्टर पे शिफ्ट करता है, तो वो सिग्नल कहता है कि नेक्स्ट पे शिफ्ट करो.
No. Change
One by one.
The flow of the program. What is the change of the flow of the program? G. Determine the flow of the program based on some conditions. Okay, can you elaborate this for C++? How do we change the flow of the program in C or C++? How do we change the flow of the program?
सर if else command से अगर condition meet होती है तो
yes. So what if you now we will also have some assembly instruction for that purpose. But if you look in C or C++, so C or C++, so the control flow, what are the example? If, else, while, do while,
switch
statement. Did you know switch or case statement? Did you remember that?
Yes,
sir.
It means it changed the flow of the program. Now let's assume I will elaborate this in C, C++. So let's assume if you are writing an instruction C is equal to A plus B, let's assume, and D is equal to C plus 5, G is equal to D divided by 2, 3. Let's assume, so this is so if like these are three different statements. So okay. So if you say if E is greater than 9, else so it means, so let's assume this is code 1. Code 1. So this is, let's assume code 1. Code 1. And this is code 2. Code 2. So if we say, okay, so if how do we do the flow of program? First, this instruction will be executed. Statement 1. Then this instruction will be executed. And typically the flow of the program will be sequential. In this case, the flow of the program. So the flow of the program will be sequential. Now, these are the, so this is an example. So this is an example of control instructions. Control instruction. And it determine. So actually, what's, it's okay. So can anybody tell me whether code 1 will be executed or code 2 will be executed? जी बताएं. जी बेटा. आवाज नहीं आ रही मेरी मुझे.
Code 2.
Why code 2? Why code 2?
सर कंट्रोल इंस्ट्रक्शन डिमांड करेगी फर्स्ट वाली होगी.
फर्स्ट वाली क्यों होगी?
क्योंकि सर वो कंट्रोल का आ रही है ना.
कंट्रोल क्या कंट्रोल कर रहे हैं?
सर
आप लोगों ने
कंडीशन
नहीं है. आप लोगों ने C++ कैसे पढ़े ही नहीं है. आप पास हो गए या नहीं?
सर जी की वैल्यू पे डिपेंड करेगा ना कि वो 9 से ज्यादा है तो फिर कोड 1 करेगा, नहीं तो
That's the reason. ये बेटा इतना आसान सी बात है या क्या है? आप लोग कर क्या रहे हैं? मेरे ख्याल आप लोग C++ में कैसे पास कैसे हो गए यार मेरे भाई? So the control instruction. So actually the flow of the program will be determined by what? Value of G. So if the value of G is 13, so let's assume if if the value of G is 13, so code 1 will be executed. If value of G is 5, जी कुछ कौन सा कोड एग्जीक्यूट करेगा?
कोड 2.
Because the condition is true, so it means that it code true. So it means if the value of G is 13, so if the value of G is 13, so the if condition will be true or false? ये बताएं.
True sir.
And if condition is false, then else will be executed. So actually now if you look at G, so G is actually determined. Okay, so now G is determined on D, and D is determined on C, and C is dependent on A and B. So it means that what is G? So G is dependent on which variable?
A and B.
A, B, and C. A, B, and C, because A plus B. So actually, if you look at this thing, so actually you can also write it like this. So in C++, you can also write this. So you can also write this. G is equal to, you can also write this, A plus B A plus B
Plus 5.
plus 5. Yes, A plus B plus 5. A plus B plus 5. So A plus B plus 5, because it is C is equal to A plus B plus 5, it's D, and divided by 3. A plus B plus 5 divided by 3. So this is the value of G. Okay. So if we so home so actually G is like this. G is this single statement. So G is equal to A plus B plus 5, and now we have divided into different statements. So G is now depending on A, B, 5. So depending on A, B, and the operation. Acha, now if you look at this instruction, if you look at this thing, which type of operation is this? It is a data transfer instruction or transformation instruction?
Transformation.
It is data transformation instruction. It is because we are performing an operation on the data. And now the value of G is determined on the contents of A and B. It also depends on the content. So if A is 0 and B is 0, so it will be 5 divided by 3. 5 divided by 3, so it means the condition will be false and code 2 will be 2. So it depends on the content of A and B. So the control instruction. So in this particular example, the control instructions, the control instruction will control operation will change the flow of the program based on some conditions, based on some values. So in this particular example, the flow of the program will be determined. The flow of the program will be determined by the content. So now I will explain this with another example. So let's assume that I'm in the class and all students are sitting. All students are sitting in sequential. All students are sitting in a row wise, and I'm asking I'm asking the name from each student. Okay, what's your name? What's your name? What's your name? So I ask the students on the in the left column, and I ask what's your name, and then I move to the next student, then I move to the next student, and then I move to the next student. And suddenly I realize, okay, so there is some guy who has raised his hand, who is sitting in the back. So he's raised his hand, and then I say, okay, I check under condition. So if somebody will raise his hand, so I change the flow of the program. I'm not asking everybody sequentially, but I will ask directly from the other student. समझ आई बात या नहीं आई? आवाज समझ आ रही या नहीं आ रही?
जी सर आगे.
Okay, so that's the point. So that's the point. So the control instruction will change the flow of the program based on some conditions. Okay. And we will elaborate this. Later on. So there are 3 types of instructions. Gee, which type of instructions are there? Data transfer instruction, data transformation instruction. Yes, add, subtract, divide, multiply, and shift, etc. Control instruction that change the flow of the program. And in C++, the classical example if, else, do, and while. And there are also some assembly counterpart we will study later on. We will study this control instruction later on. Okay, now we move to the status register. So okay, so whenever there is an operation, so whenever there is an operation, so in that operation. So whenever there is an operation, whatever operation is this, whenever there is an operation, whenever there is any operation, the destination will change. G, what is the destination? What can be the destination? G, what can be the destination?
So G.
No, what is G? What is G? You बताएं.
Sir, variable है जिसके अंदर वो value transform होके place.
In a microprocessor, there is a source and there is a destination. G. Destination can be what?
Register. Sir,
Register or memory.
The destination can be memory or register. So okay. So whenever there is an operation, any destination will change. Okay. Okay. So the destination, where the destination is mentioned. So where the destination is mentioned. On the left hand side or right hand side?
Right hand side.
Left.
Said right hand side.
Left.
साइड। बेटा आप कब आप मेरे ख्याल से कंसंट्रेट नहीं कर रहे आप जो कह रहे राइट हैंड साइड। कितनी दफा बता चुका हूं खुदा के बंदे, आपको कितनी दफा बता चुका हूं। ये देखें, ये आपको कैन यू सी ऑन द ग्रीन डेस्टिनेशन इज R9, सो सोर्स इज ऑन द राइट हैंड साइड। नजर आ रहा है आपको या नहीं आ रहा? बेटा
जी सर।
आवाज आ रही है या नहीं आ रही? हाँ
आ रही है सर।
लेकिन आप कैसे कह सकते हैं कि डेस्टिनेशन इज ऑन द लेफ्ट हैंड साइड, राइट हैंड साइड? Please try to concentrate on lecture, please. So whenever there is an operation, the destination is changed. The destination can be a register or memory, and where the destination is mentioned in any instruction, the destination is mentioned on the left hand side of any instructions. Okay, so now let's assume we can call it like this. So there is any operation, an operation or opcode. We can call it as opcode, and destination and source 1 or source 2 is optional. This is optional. Okay, so this is optional. Okay, so now let's assume if we say move R3 $1 2 3 4. So what in this example, what is move? बताएं बेटा.
Opcode.
Opcode. What is R3?
Destination.
What is this one? Am I right? And source 2 is mentioned or not?
No.
No. Okay, this source 1, it is memory or register?
Memory.
Memory. Which addressing mode we are using?
Direct.
Very good. Okay, so now, now this is, so now move to another example. So now let's assume we have this add R3 R4 #5 G. If we look at this example, if we look at this example, G बताएं, what is add?
Opcode.
What is R3?
Destination.
What is R4?
Source 1.
What is #5?
Source.
Which addressing mode is this?
Immediate.
Immediate register.
Okay, so now whenever there is any operation, the destination will change. Okay, now the operation can be a move instruction, the operation can be a data transfer instruction, the operation can be a data transformation instruction, or the operation can be a branch instruction or control instruction. So this opcode, so if you look at this opcode, so this opcode may be a data transfer instruction. And it can be either a data transformation instruction. Okay, now if you look at move is a data transfer instruction or data transformation instruction. This move.
Data transfer instruction.
Data transfer. And what about add?
Data transformation.
So it is a data. Mic बंद कर दे please. ठीक है? It is a data transformation instruction. So whenever there is a change, so actually when you change the value, so the destination will be changed. So the destination will be changed. Now we move to the status register. G यहाँ पे. So the status register lies within a microprocessor, and this status register has different bits. The bits are called as N, Z, C, and V. So the carry flag, so C stands for carry flag. So the carry flag will be 1 when any operation will generate a carry. Whenever any operation will generate a carry, so the carry flag will be 1. G, whenever any operation will okay, so and for that operation you need some operands. You need some operands. G, how will it look like? जी बताएं, बता सकते हैं? Can you give me an example?
सर किसी नंबर्स की एडिशन या
Yes, whenever there is an addition, so the carry will be generated. Okay, in our architecture, what was the size of the register? What was the size of the register? What was the size of our register what was the size of the register in our architecture? जी बताएं, what was the size of the register? How many bits? बेटा आपसे सवाल कर रहा हूँ. 16 bits. So 16 bits. So let's assume, let's assume this is an instruction: add R3, R4, and R9. Okay. So now let's assume we have add the contents of R4. So R4 has some contents. And R9 has some contents. So let's assume that the contents of R4 is, now I'm representing in hexadecimal 0, 0, 2, 2, and then 0, 0, 5, 5. Okay, so if you add these two numbers, so 0, 0, 2, 2, and 0, 0, 5, 5, what will be the result? 0. Is the carry generated? यहाँ पे carry generate हुआ है अभी या नहीं?
No sir.
No carry. So in this case, so it means that add the contents of R4 and R3. So let's assume the old contents of R3. Let's assume the old contents of R3 is 0, 0, 0, 0. It will be overwritten, and the new contents will be 0, 0, 7, 6. And what will be the value of carry flag?
0.
0.
So the carry flag will be. क्या नहीं आई? So now move to another example. Move to another example. So if we are doing like this, so if we move to another example, so let's assume add. Okay. So add R5, R10, and hash. So 2, 5, 0, 3. Okay. So now for this we need to have, let's say, okay, now let's assume that the contents R3, R10. So let's assume that the hash, now it is also in hexadecimal, so dollar, I'm using the dollar symbol. So this is in hexadecimal. Which value is this one? What is this value? Which addressing mode is this?
Immediate.
Immediate.
So this addressing mode is immediate addressing mode. Okay, so now let's assume that the contents of R10. So let's assume the contents of R10. So let's assume we have the contents of R10, and the content of R10 is F2, 0, 0. So what we are doing now? So we are adding F2, 0, 0 with the content 2, 5, 2, 5, 0, 3. So we add this to this 3. This is 0. 5 plus 2, 7. Okay, now for F, if you convert it into binary, so it is 1, 1, 1, 1. And if we convert 2 to binary, so this will be 0, 0, 1, 0. Am I right or not?
Yes sir.
Yes, sir.
So it will be 1. 1, 1 is 0. There will be a carry. 1, 1 is 0. There will be a carry. 1, 1 is 0. There will be a carry. So actually it will be here. So the result will be 0, 0, 0, 1. So the result will be 1. And now we have generated a carry. And the carry is 1. So in this case, what will be the value of C flag in this particular example?
1.
The carry flag C will be 1. So if you add two numbers, so now we have added two numbers. So we have added this number and we have added this number. So in this case, a carry is generated. In this case, a carry is generated. Okay, if you have F, what is the next digit after F? 0, because you are adding 2. 0 and then 1. That's the reason that 1 is generated. So F plus 2 is actually 1, 1. It's a binary operation. So now in this case, a carry is generated. So whenever there is an operation, okay. So now if there is an operation, so this is an operation. So this is an operation. There is an operation. What is the example of this operation in this example? The operation is now an add operation. We perform an operation. So where will this go? Where will this go? 1703.
R3.
Destination. And what is the destination in this example?
R3.
So we perform an operation. That operation is an addition, and that operation generated a carry. So this generated a carry. So now when this generated a carry, so this C flag will be 1. In this example, this operation. So the new contents. What will be the new contents of R3? The old contents will be overwritten. So in this operation, so this operation does not generate a carry. So this does not generate a carry. Does not generate a carry. And if you look at this, so this operation generated a carry. So the carry flag will be 1 when you perform any operation and a carry is generated. बेटा समझ आ गई या नहीं आई?
Sir.
Okay, very good. Okay. So now we move to the 0 flag, Z flag. So now Z flag. So the Z flag will be 1 when the result of the operation is 0. So when all the contents of the operation is 0, so the Z flag will be 1. So I will explain this with an example. So now let's assume we move in an example. So we move in an example. So let's assume the example. So if we say move R3 hash 0, what we are doing now? Let's assume that the contents of R3 is 5, 5, 5, 3. What will be the new contents of R3?
0.
So $0, 0, 0, 0. So since the whole contents of the R0 is 0, so Z flag will be 1. नहीं समझे बेटा? So Z flag will be 1 if the result, or we can say a destination. Z flag will be 1 if the result is 0, and Z flag will be 0 if the result is what? G is what?
0 number. Other than 0.
Is non-zero. It can be less than 0. It can be greater than 0. In case of negative number, it can be less than 0. And in case of positive number, it will be greater than 0. So if it means that if the result is non-zero, so non-zero means, so if we say non-zero, so if we say non-zero, so if non-zero means result can be greater than 0 or less than 0. So it depends on the contents of it depends on the contents of thing. Okay, so now let's assume. So let's assume if we say add subtract R5 R3 hash 2. So now let's assume that if we have R3 and the content of R3 is 0, 0, 0, 2. What you are doing? You are subtracting R3 0, 0, 0, 2, and you are subtracting 0, 0, 0, 2. What will be the result?
0, 0, 0, 0.
0, 0, 0, 0, 0, 0. What will be Z flag now?
1.
1. The Z flag will be 1. No, sorry. This I made a mistake. I made a small mistake. So actually, let's assume this is not R5. Actually, it is the R3 will not change. So this is R5. R5 will change. Okay. So this is I made a small mistake. Sorry, I made a small mistake. So let's assume you have this R3 and R3 has 0, 0, 0, 2 and R5 is, let's assume the value of R5 is 1, 1, 1, 1. So this will change and the new contents will now be 0, 0, 0, 0. So now our case is the source will not change. So the Z flag will be 1 in this example. बेटा समझ आ गई आपको? So now let's assume we have another example. So now let's assume subtract R4, subtract R4, subtract R4, R3, and hash 1. So now let's assume that the contents of R4 is let's assume the content of R4 is F, 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 and F. You are taking the value of R2. 2, 0, 0, 0, 2 and you are subtracting 0, 0, 0, 1. So what are the new contents?
0, 0, 1.
0, 0, 1. So what will be the new contents of R4? What will be Z flag?
0.
Because the result is non-zero. Okay, so now the Z flag will be 1 when the result of the operation is 0. What about negative flag? G and flag. So the negative flag. So the negative flag will be 1 when the result of the operation is negative. G. How you represent a negative operation? G. But when the result of operation is negative. G बताएं बेटा. How do you represent a negative operation?
वो 2's complement के बाद 1 आ जाता है उसके साथ.
Actually, if you represent a negative operation, actually how do you, so the negative operation, negative operand is typically presented by the most significant bit. याद आ रहा है या नहीं आ रहा? If MSB is 1, then the most significant bit, not byte, bit. If MSB is 1, MSB. If MSB is 1, then the operand is negative. Otherwise, operand is positive. समझ आ रही या नहीं आ रही?
Yes, sir.
So now to explain or to elaborate this, I will take a very small example of a 4-bit operation. So let's assume we have a 4-bit. So let's assume we have 4-bit. B4, B4, not B4. I will just erase it. So B3, B2, B1, and B0. So it's a 4-bit operation. So it means that the range will okay. Now make it. Let's assume I will make it as a 3-bit operation. So 3-bit operation. Okay. So this value will range from 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0. Okay. Okay. 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay. So now if it means everybody has a weight, so it is the weight is 2 to the power 0. It is 2 to the power 1. 2 to the power 0 is 1. 2 to the power 1 is 2, and its weight is minus 2 to the power 2. So it is -4. So okay, all of them are 0. So the result is actually, if you look at it, the binary, so the value is 0. If you look at 1, 1, so it is 1. It is 2. It is 3. If you look at 100, so what we are adding? 100 means -4 plus 0 plus 0. So it is -4. If you look at 101, how does 101 is represented? -4 plus 0 plus 1. What is the value?
-3.
-3. And if 110, if you look at 110, so it is -4 plus, because its weight is 2. Its weight is 2. -4 plus 2 plus 0. What's with the value? And 111?
-1.
Okay, if you look at this operation, now for the sake of simplicity, I have assumed a 3-bit data. So if I have assumed a 3-bit data, so in this case, in all these cases, in this operation, the result is negative or positive? Negative. In this particular example, the result is negative or positive? 1, 2, 3.
Positive.
And for the third example, what is in this case? The result is what?
Null.
0. So in this case, if for the 0, g will be 1. If the result is positive, so g will be 0. So in all cases, in all these cases, g will be 0. Okay, if the result is positive, so n will be negative, n will be 0. And if the result is negative, n will be what?
1.
1. When n will be 1? Actually, if you look at this data, so actually n is actually the most significant bit. So if the result is negative, if the MSB is, so the result is negative. So can we write it like this? That the So can we write it like this? That the result is negative. So can we write it like this? That the result is negative if the most significant bit of the data is 1. So the result is positive. Most significant bit of the data is 0. Am I right or not?
Right.
So can we write like this? N is equal to actually the most significant bit. So it's the N is actually the most significant. N is actually the most significant bit of the destination of the source. अच्छा